Mosem, and I welcome you all. Ladies and gentlemen, Assalamu alaikum and good day. I'm Hazima Mosem, and I welcome you all to another exciting Comstech webinar. The title of today's Comstech webinar is Shrinking Indus Delta, Current Status and the Way Forward. This webinar will be delivered by Professor Dr. Altaf Ali Sayal. Professor Sayal is the Chairman of Department of Land and Water Management. He is also Director of Office of Research, Innovation and Commercialization at Sindh Agricultural University, Tandojam, Pakistan. We are very grateful for to Professor Dr. Sayal for his time and for agreeing to deliver this lecture. With this, I request Professor Dr. Muhammad Iqbal Chaudhry, Coordinator General Comstech and Director ICCBS, to welcome and introduce our guest speaker for today.
Bismillahirrahmanirrahim. Assalamu alaikum. Good morning and good afternoon, ladies and gentlemen, scholars from different countries. Yet another very important seminar on a topic which is extremely important, not only for Pakistan, but also many countries which are all around Pakistan. Indus is extremely important for the history, culture, and for the survival of literally millions of people in this country, and it is also the cradle of civilization, from Neolithic civilization to Indus River civilization. This is a river which has given birth to many cultures, many civilizations. Unfortunately, this is in crisis, and there are lots of environmental problems which Indus face today. So do the population which actually depend on Indus. And this is the topic of today's presentation by a very competent person who has achieved a lot in his life working in this area with complete dedication. Professor Dr. Altaf Ali Sayal is currently working as the Chairman of Department of Land and Water Management, as well as Director COIC at Sindh Agriculture University, which is one of the legacy institutions in agriculture sciences in Pakistan. This is one of the oldest agriculture universities in the country. Dr. Sayal has also served for many years at US-Pakistan Center for Advanced Studies in Water, Mehran University of Engineering and Technology, which was a major project supported by USAID and Higher Education Commission. He, in 2011, he got Endeavour Research Fellowship funded by the Australian government for postdoctoral research on soil, water, and crop environment at CSIRO, which is equivalent to CSIR in Pakistan, in Townsville, Australia. Dr. Sayal was also awarded Fulbright Fellowship, and he worked at the University of California at USD ARS Salinity Laboratory in Riverside, the USA, during 2007 and 2008. He got his PhD in 2001 from the Cranfield University, the United Kingdom, from a scholarship which he won on the basis of merit from Quaid-e-Azam University. It's called Quaid-e-Azam Merit Scholarship, I'm sorry. He earned his master's degree in irrigation and drainage and bachelor degree in agriculture engineering in 1990 from Sindh Agriculture University, in Pakistan. Dr. Sayal has expertise in remote sensing application, GIS, climate change, environmental water resource engineering and management. He is also one of the leading experts in the field of irrigation and drainage, and has been working with many organizations in the country and beyond. And therefore, we consider this presentation an extremely important one that addresses some of the most enduring challenges which our country face, which Indus faces, and which unfortunately many river systems of the world, many oasis systems are facing also. So this is a talk which may focus on Indus River, but this is something which is lesson learned for the others. With this, I would like to invite Professor Dr. Altaf Ali Sayal for the presentation. He's disconnected, Khazima.
So let me ask him to connect. यार एक नंबर मिलाना है, एक मिनट आपको नंबर मिलाते हैं, बताते हैं। हाँ मिलाएं, 335-334-0405।
Okay, so by the time
hello, I am back. Actually, I got a
yes,
problem.
we can hear you now, and we're looking forward to have your exciting presentation about the status of Indus Delta and the challenges which we face today. Dr. Sayal, please.
Yeah, please. I am going to share my presentation again because I got disconnected. It's a net problem here. So we are back again. Yes, can you see it now, the my PPT?
Yeah, we can see that. If you can kindly, if you can widen the screen, you just have a full slide, please. But we can see it.
Yeah, thank you. So some facts about the Indus Delta. The Indus Delta is the 5th largest delta of the world. And it's also a Ramsar wetland of Pakistan, one of the Ramsar wetlands, and it supports the 7th largest mangrove system in the world, whereas those mangrove systems for the arid zone, so it's the number 1 in the world, and whereas it's also very vulnerable due to climate change, other anthropogenic activities. There were 17 river mouths in Indus Delta once, and now there are only 2 active creeks, Khobar and Khar. With the passage of time, out of 17, now there are only 2 left. The active delta now occupied about 12,900 square kilometers in 1833, which has now reduced to only 1,000 square kilometers, about 92% reduction in the delta area. And the shoreline is exposed to face the high energy levels due to the wave energy and its impact on the erosion. So these are the major of the coastal Sindh delta, Indus delta: coastal erosion, soil salinity, seawater intrusion, declining river flows, climate change, shrinking active delta, and of course all these combine and affect the livelihood of the people living in Indus Delta. This is the location of the Indus Delta, where it is located in Pakistan. It's at the tail end of the river Indus, where Indus meets with the Arabian Sea. So this area we have studied, and we have studied different factors, different parameters which are impacting the Indus Delta, which are responsible for shrinking the Indus Delta. First of all, we found a challenge that where we would fix the boundaries of the Indus Delta, because different people have given different areas for the Indus Delta. Some have mentioned that it's about 4.14 million hectares, some say 0.6. So there were different figures you can find in the literature about the area of the actual Indus Delta. So that was a big challenge for us to fix out the boundaries of Indus Delta. Then we would start our work on the different parameters of Indus Delta, which were impacting the Indus quality, the Indus Delta livelihood of the people which are living there, mostly the fishermen.
Sir, I would request you to please switch on your camera so that the participants can also see you.
Okay. I'm going to.
Thank you.
Okay. So, is it on now? I guess, yeah.
Yes, so we can see you.
Yeah, we collected different old maps, which were one of them is 1833 and the other is 1883. During that time, there was one the Indus River distributed in different creeks and different rivers. So at that time, there was one in the river that was the Pinyari River. So we took it that point as the apex of the delta, and then we set out the boundaries of the delta. So in this way, we had the delta of about 18,000 square kilometers. The area of delta was 18,000 square kilometers. Actually, I had a problem with presentation. It's not moving at a moment. Trying. Okay, so this is the delta. After fixing the boundaries, we have this delta boundaries, and the creeks which are abundant and which were active before. I have given the names of those creeks. Only the Khobar and Khar, which are at these Khobar and Khar here. These are the two active creeks here. This is Khar, this is Khobar. These are active. The rest one are now not active, but they were used to be very active up to the 1833. Now, the first one, the biggest challenge to Indus Delta, threat to Indus Delta, is the coastal erosion. And we quantified that how much damage has been occurred from 1972 to 2017. And we downloaded different landside images of different years. And we analyzed with the digital shoreline analysis software, DSAS, and this is the layout how we find out the shoreline. We draw the shoreline, digitize those one, and found the shorelines where were during those days, and we put it into the software, DSAS, and we divided this whole shoreline from Sar Creek to Fiti Creek. It's near to Karachi in different 4 zones. So zone 1 was from Sark to Wari Creek, other one was the Wari to Khobar Creek, Khobar to Dabo Creek, and Dabo to Fiti Creek. So 2 zones were on the first and second zone was on the left side of the river Indus, while the zone 3 and 4 are on the right side of the river Indus. And the number of transects are given in the table. Spacing between each transect was 200. So after every 200 meters, the data was there in the software, and we found how much is the erosion or accretion there, and overall what are the results. So, and also I calculated manually that how much shoreline has been shifted landward or seaward. So this is the erosion and accretion rate for each zone. For zone 1, the rate maximum was 45.69 meters per year, whereas for accretion at that point was 9.86. Similarly, for the other zones there, so more erosion was on the left side of the river Indus, and that area is actually is in the geographical boundaries of Sijawal district, whereas right side is in the geographical boundaries of Thatta district. This is the variation in the net shoreline movement at different places. And so these are the up to 300 kilometers, since it was 280 kilometers we studied, and it's again that where is the accretion and where is the erosion. So from Sar Creek to Fiti Creek and Khobar is actually the river Indus, from where now it's discharging into the river into the Arabian Sea. This is the net shoreline movement from 1972 till 2017. And for zone, it was about 1,098 meters, whereas for the zone 2, it was 1,200 or 1.24 kilometers. Zone 3, 687, and zone 4, 411. So there was the erosion, and more erosion was on the left side of the river Indus. and whereas it was less on, there were less on the right side of the Indus. There is a valid reason for this one, because on the right side of the river Indus, the mangrove population is very high. The dense mangroves are there. Also, that side is a little bit slightly steeper as compared to the left side of the river Indus. The area on the shoreline on the left side of the river Indus, that one area is very, very flat, and the westerly, southwesterly winds, they strike directly to the left side of the river Indus side, the shoreline, which is on the left side of the river Indus. So these are these plots show where is the accretion, where is the erosion along the shoreline of the river Indus. So mean erosion rate was for all the zones was 39 meters per year, and mean accretion was 21 meters per year. So net shoreline movement since 1972 till 2017 was 860 meters. So overall, at all the zones, there was the erosion, and overall erosion was throughout the Indus Delta. So this is actually the movement, where is the erosion, where is the accretion. This is the calculated from with the manually calculated by drawing the transects along the shoreline. And this is the area which is in the blue color, which reflects that these areas are permanently now become the part of the sea. These are now no more tidal floodplain area, but rather they are now permanently the part of the sea. So this is the conclusion for the first threat which Indus Delta faces. So left side of river Indus is more vulnerable to the right side of the river Indus. The net inward shift of the shoreline is 860 meters. And while when we calculated with the manually, it is 1,295 meters. So because the space between transects in manual calculation was large, so therefore there is a variation of 400 meters. Higher shoreline change rate was 34.3 meters per year, and it was observed from 1990 to 2017, whereas from after 2072 to 1990, it's only 28.4. So after 1990, there is a more shoreline change rate. Now seawater intrusion. So seawater intrusion, I divided into the surface and subsurface seawater intrusion. So surface seawater intrusion, we can see subsurface is invisible, but it impacts the groundwater, it impacts the agricultural crop production. So this is a tidal floodplain area, and which is equally occupied by the sea as well as the land. And here, that's the area where mangroves flourish, where we grow the mangroves, and that's if the mangroves are there, that's the first defense line against different coastal threats, especially the tsunamis, the cyclones, and sea level rise. So this is the first defense line, and it's a huge area, which is, you can see here in 1990, how much was the tidal floodplain area, and 2017. So in both of them, you can see one is the satellite image, other one is the classified image. In 2007, more area has gone under the water compared to 1990. So this is the tidal floodplain area, how it varies. And so there is a gradual increase in tidal floodplain area from 1972 to 2017. So that area, the mud flats, they are increasing with the passage of time. So tidal, there is an increase of 7.1% in the tidal floodplain area. And it's more on the left-hand side, and it's nearly double tidal flood plain area is on the left-hand side compared to right-hand side of the coastline. Means when I say left-hand side and right-hand side, it means on the with respect to the river Indus. So I also contacted with the local communities and asked their view that how can we avoid this surface seawater intrusion. So majority of them say that if the river flow is regulated and it's constant flow of river is coming there and it's feeding the coastal belt, then we can have we can mitigate the impacts of the sea level rise and other impacts, and we can meet the environmental requirements. Some people say that we can have the levees. 38% say that we can have a levee at the boundary between the tidal flood plain area and the land. And 2% say that if we increase the mangrove plantation, we can have a better results. Also, some people say that there should be levees and levee and mangrove. Some say that levee and river flows, but the major chunk of people response was the river flow and the construction of a levee along the tidal flood plain area. Seawater intrusion, subsurface, which is invisible to common people, but that's moving slowly landwards. We took the samples from different areas within the delta, and those were mostly the hand pumps which were installed there, and those were the samples were analyzed at the US Pakistan Center for Advanced Studies in Water at Mehran University of Engineering Technology for different parameters to find out whether there's a seawater intrusion, these wells are impacted by the seawater intrusion or not. So this is the sampling of the groundwater of the delta at different locations. And how we can say that what parameters we consider that whether that one has been impacted with the seawater or it's because of the original the water was there. So we have taken these parameters. One is the high levels of the chlorides, and that's above 250 milligrams per liter. Then ionic ratio of chloride and to carbonate and bicarbonate. Simpson ratio, high correlation among chloride and magnesium, chloride and bicarbonate. So these are different parameters, 5 we considered, and then we analyzed accordingly the samples, and we found that the subsurface seawater intrusion has touched the Thatta and Sejawal districts. So around about 85% of the delta was impacted with the subsurface seawater intrusion. So this is here. So 88%, I say 88, but 85, but it's 88% of the Indus Delta is impacted with the subsurface seawater intrusion. Now, shrinking delta, how delta has shrunk with the passage of time. So initially in these boundaries, the large one, these boundaries are far from the 1833. Now the active delta is this one, which is boxed in red color here. That's the only active delta left where the fresh water of the river Indus reaches. The rest one, there's no any creek, any estuary are there. Only estuaries are remaining here. And the river water reaches directly to this portion. So active delta in 1833 was about 12,900 square kilometers. And in 2017, it was only 1,070. And some of the people have reported active delta up to 1,100 square kilometers. Some have reported 1,200. So it's around about same. My calculations are also similar to those some have done already. Now, the major factor which is impacting the Indus Delta is the freshwater flow, decrease in freshwater flow of the river Indus. So this is a graph here which shows the supply of fresh water through the Indus to the delta from 1937 till this year, which last year means from 2021 to 22. And in 2021-22, the Indus Delta received 2.4 million acre feet. And sometimes, means few years, 50 years ago, it received up to 135 million acre feet, but slowly and gradually it has decreased. In the years 2001 and 2-3, there was not 0.1%, 0.1 million acre feet water has gone. And now it is 2.4 million acre feet of water. But as per the International Panel of Experts, the environmental requirement of Indus Delta is 5,000 cusecs daily, and after every 5 years there should be the flow should go 25 million acre feet. So in this way, if we calculate every year, the Indus Delta requirement is 8.6 million acre feet. And this graph shows the number of days which the delta did not receive any flow. So if we see this graph, the initially from 1956, 57, and initially years during that time, all throughout the year, the Indus Delta received the flow, freshwater flow. But with the passage of time, the number of days in which the delta received no water increased. And in some years, now this year, the number of days the delta received no water has decreased, because now the strategy has been a little bit changed. Now they are allowing up to 50 to 500 cusecs daily to Indus Delta for major portion of the year. Now, soil salinity issue in the Indus Delta. These are some snapshots of the soil salinity. Such kind of land you can find in the Indus Delta in hundreds, thousands of acres are lying barren because of the soil salinity and unavailability of the fresh water there. We sampled the delta, and these are the sampling locations, and we analyzed those soil samples to determine whether the soil is saline or alkaline, and what type of soil is there, what texture is there. These are some snapshots of the soil sampling. And that team is with me, one assistant professor and few research assistants, and we sampled the entire delta and we analyzed at the center. So we found that the silty clay was the dominant soil texture there, followed by clay loam and clay, and then the other, because at the tail end of the river Indus, mostly the fine texture soil particles reach. That's why the clay is dominant here. And this is the spatial variation of the soil texture in the Indus Delta. Then the soil salinity in the layers of 0 to 20, 20 to 40, and 40 to 60. And mostly the saline soil is spread over large areas, especially the tidal floodplains, and then followed by sodic, and then saline sodic soil. So saline sodic soil is at the tidal floodplains, and sodic is near to that one. And if we come towards the irrigated areas, the saline soil is more there. And some areas are normal soils, which you can see from the green color. But mostly along the tidal floodplain area, we have saline sodic soils. So this is the area under each soil class and the percentage for 0 to 20. So you can see the saline sodic soils occupy about 46% of the area. And normal soil is about 16% of the total Indus Delta. So this is the actually soil salinity map, which I developed using the different techniques, and the yellow color shows the saline areas, and the whitish color are the others, means those are the sand and the rocky areas there, because there's a muckly hills there, so those are shown with the white color. Mangrove and plantation within the tidal floodplain area. So these are the different mangrove plantations during the mangrove populations during different years from 1970 to 2017. And this reflects that the mangrove population decreased initially, but afterwards it has increased. And especially when some of the NGOs and government took initiatives in the early 2000s, in 2005-06, so they have planted a lot of areas, and still the plantation is going on, especially on the left side of the river Indus, which is more barren, and there is a lack of the mangrove plantation. So government of Sindh and the Asian Development Bank is taking interest, and they are going to plant vast areas with the mangroves, especially on the left side of the river Indus. So this is the quantification of the mangrove plantation with the and it shows that currently in 2017, about thick population of mangrove forest, thick mangrove forest was on the 5%, and 55%. This is, I'm telling about the tidal floodplain area, not the whole Indus Delta, only the tidal floodplain here. They are mud flats. So 55% are the barren, 7% are thin forests. Water was on 31%, and thick forest was on 5.6%. So these are the forest vegetation cover or vegetation mask of the Indus Delta. And in 2010, we had floods. This is actually 2010 February. Sorry, 2011 February. So after floods, we had greenery has increased, the greenish area has increased, the vegetation mask, you can see the more green, but as compared in 2017, again, the greenish area has decreased, the vegetation has decreased in the delta because of the less cultivation of the crops. So how the area under vegetation has increased and decreased with passage of time. Now, contamination of surface and groundwater bodies with different resources. We took the samples from different hand pumps and analyzed for the quality of water for drinking and other agricultural purpose, so far, especially for drinking purpose. And we see that the very limited area has the TDS below the permissible limit, where below the 500 milligrams per liter of ppm, while the vast areas are above the permissible limit. That's why people usually take the raw fresh water from the canals, river, to drink those one, though that's also contaminated, but they have no other option to drink that water which is coming through the canals, water courses, and distributaries and miners. So if we see the arsenic level at some areas, most of the areas is less than 10, which is the per ppb, which is permissible limit. But at some areas, it has gone up to the 199 ppb. So some areas they are vulnerable, and the government take initiatives to guide the people that how and provide the alternatives so that the people may have the alternative to drink that one and have the healthy water or safe water. So I also took the perspective of the people and the people of the area were interviewed. About 500 people we interviewed in the Delta, and the results came, and that's in the pie chart, that the 60%, 67% people said that they have the saline water in their area. 4% said that sweet water is available there, and 29% said that the water is brackish. And how they use groundwater, 76% people use groundwater, and then surface groundwater actually is not a groundwater. Actually, that's a filtration water. They install their most of the people, not all, but most of the people install their hand pumps having depth up to the 20 to 25 feet along the water courses and miners and distributors, so that the water which seeps from those one be intercepted and drawn for the drinking purpose. Climate change impact. So climate change, I got data from World Claim from 1960 and 1990 and plotted for each month that how the temperature varies. And when I compared that one from 1960 to 1990 and 1990 to 2015, when I compared that one, we can see that the rainfall has shifted. Usually, previously, it used to be fall during the month of July. Most of the rain came that one, but now it is shifted to August and September. No doubt it was in August as well previously and September, but the most of the rain used to fall during the July. But nowadays it has shifted towards the August and September, and we are now receiving more water compared to previous years in September as well. So these are the variations of the rainfall and temperature. So this is the temperature, how temperature varies. And temperature has, you can see in June and July has increased, and April as well. Well as in December, the temperature has decreased, means more temperature during the summer and less temperature during the winter. So that is a shift in the temperature. You can also see we had calculated the land surface temperature for 1990 and for the 2017. And we found that on average, the mean temperature of the land, which was 20.22 centigrade in 1990, now in 2017, it was 23. It was the same date, almost same date of the February. So 23.84, so about 1.8 degree temperature has risen for the surface. And this is the precipitation and temperature, and this is the one of the major issue for the delta, which is threatening to the Indus Delta, is the sea level rise. If we see this, the elevation map of the Indus Delta, that most of the area, 60 to 70% area, is within the 15 meters of the about 5 meters, sorry, not 15 meters, but 5 meters of the 0 to 5 meters. Most of the area is that one. So if the sea rises, a lot of area will be submerged, because Indus Delta is a very, very flat area. And that's why a slight rise in the Indus Delta will, a slight rise in the sea will impact the Indus Delta large. And also, there's another issue. There's a lot of oil exploration along the Sar Creek area and this Sijawal district, and that also impacts in terms of subsidence. So land subsidence and sea level rise. So both are impacting the Indus Delta. So this is, I created one animation that if the water level rises for 5 meters, how much area will be submerged. So you can see that if the water level due to tsunami or any reason increases, so more than 50% of the Indus Delta is going to be submerged. Now, the recommendations are the way forward. So first of all, the main demand from the local communities is that there should be a levee constructed at the periphery of the Indus Delta. It will will serve as the road also, because it should not be only the levee, but above it should be a coastal highway. And some portion of coastal highway is already constructed at the periphery of the tidal flood plain area. About 38 kilometers are already constructed, rest one about 200 kilometers needs to be constructed, and it should go to the Ali Bandar, and it will not only stop the surface seawater intrusion, but it will also provide the way of communication, transportation of the fish production to the markets of Karachi, and the fishers and the community which are living along the coastal area have a very quick and easy access to the Karachi and other big cities of Sindh and Pakistan. Another one is that there are old rivers and channels which are now abandoned, and now people have encroached those one, especially there are the Ochoto and Pinyari river, and those needs to be revived. When there is a high flood like in 2010, those channels can be used to divert the flood pressure from the river Indus, and through these channels the water will go directly to the sea. So those channels will also help in mitigating the subsurface seawater intrusion, and also those will help in providing the drinking quality water to different communities living away from the river Indus. Also, the tail end for the Indus Delta, the environmental requirement of the delta needs to be fulfilled, which is 8.6. It should not be said that that's a wastage of the water. So as the International Panel of Experts has given the recommendation that at least 8.6 water is needed. So there's a mechanism can be developed so that the water should go. And one of that one is if we can have the Manchar Lake, which is upstream, it can be used as a storage, and water during the flood time can be stored there and can then be used because it's very close to the delta. Lakes in the delta, there are plenty of lakes, natural lakes in the delta. During the rainfall time, rain needs to be harvested there, and those lakes are nowadays, most of them are saline. So these lakes needs to be revived, and water during the floods and when there's the monsoon period needs to be collected there, so that not only those lakes will recharge the area and the help in mitigating the subsurface seawater intrusion, but the water which is collected, stored on those lakes can be used for drinking purpose and for the agricultural purpose. Cultivation of value-added halophytes such as Salicornia, seawater ester, spartium. So there are different halophytes needs to will be helpful to cultivate in the tidal floodplain areas along with the mangroves. So they will provide the fodder to the camels, because in that area plenty of camel, a lot of mangrove camel population is there, and they have always issue of the fodder. So this will serve the purpose of the fodder in that area. And also the mangrove plantation should be done. If there is a thick mangrove plantation, how it will be help? It will help in silt will be trapped there, and it will help in the accretion of the shoreline. The government should ban on the overgrazing and cutting of the mangroves, and the shrimp and crab farming. Nowadays, the fish production in that area has decreased, and people are, because it's people are catching very small fish there. So fish production has tremendously decreased, and there is also a problem of the pollution. Because of pollution, because of the people, their selves, they are catching a lot of small fish. So the fish production has decreased. Now people have started the catching crab, and they catch it and sell in local market, and then that crab is going to the Karachi Ibrahim Hedri, and where it's processed and sent to different countries, and they earn a lot. So shrimp, aquaculture and crab should be encouraged, and for the people. Another important thing is this is the tourism industry. If you go in the mangrove population area, you will forget Europe. a very, very beautiful creeks are there, mangroves are there, and very good blue color water is there. And it's a marvelous, really, it's a very beautiful. And if the government encourage the tourism industry, so delta tourism needs to be encouraged so that the people have the livelihood there, and that area be protected from the different pollutions and that one. So that area, the tourism industry needs to be increased in that area. Thank you very much. Hello. Any question?
Hello, Assalamualaikum, sir. Thank you very much. It was a wonderful presentation. I'm sorry, my mic was actually mute by the Adam. It was a wonderful presentation, and you can see many comments in the chat box. I would request our participants, if they would like to ask some questions from our speaker, they can post it in our chat box.
Yeah, if you can take one or two question, I can respond. The questions are welcome.
Yes, sir. I'm waiting for the questions from the participants. If we have any question. So here is a question from Miss Komal Rajpal. She's asking, well, actually, she's asking a general question that how the climate change is affecting crops. So I think she probably wants you to answer that with regard to the change in the whole water resource situation as well towards the agriculture.
Yeah, actually, the climate change, when we are talking about Pakistan is at the bottom to produce the greenhouse gases. But when we look at the impact of the climate change on the Pakistan, it's at the top. And it's you know that it's at the in the first 7 countries at the ranks at the 7 country which is most affected with the climate change, and especially the southern part of Pakistan, Sindh, and this especially the delta. When we look at the delta, the temperature you saw from my presentation is going to increase. So certainly it will need more and more water to meet the crop water requirements. The water resources in Pakistan, so what we receive the flow as well as the rainfall is erratic. I mean, sometimes we have plenty of water, sometimes we have droughts. So it's because of the climate change. Another is the temperature. So temperature and the shifting of the trend. Now we saw the rice crop in June and July. Previously in the delta it used to be cultivated in May. Now it has shifted to June. So 1 month is the delay. Similarly, if we see the Larkana, the people used to sow the rice crop in the June. Now it is shifted to August, 2 months back. So it's all climate change. And during that time, sometimes the water shortage is there. So the river flows, and at the upper region of Pakistan, the glaciers, they say that it's melting, except some part of the glaciers that they say that it's increasing, but in Himalayan region overall, if we see that the glaciers are melting, so there's a big impact on the of climate change on the Pakistan and India and especially the Sindh, because it's at the tail end of the river Indus, and it's arid and completely depending upon the river Indus. I would say that the river Indus is the lifeline of Sindh.
Thank you very much, sir. With this, again, thank you very much for your time and for the very wonderful presentation.
Thank you.
Yes, so here is another question from Mr. Ali Raza. He's asking, can you please suggest that what immediate actions should be taken in order to avoid sea water intrusion before we can find any permanent solution?
Yeah, actually, I know because I have some friends who are working. So at a moment, there's a one project going on, Sindh Coastal Resilient Project. Under that project, they are going to plant a lot of mangroves as a first defense line. And then there are huge areas which are barren. So they are proposing government of Sindh to have the forestry, especially the salt tolerant plants should be grown, cultivated in that area, so that after first defense line, the second defense lines of forestry would be there. So that will help in seawater. And then the levee is very important, because and the third one is the water, especially because irrigation canals are there and distributors are there, miners are there, water courses are there, and they supply fresh water, and they are offtaking water from the Kotri barrage. So it's my own observation, because I visited almost entire delta and gone up to the sea, and I have seen there. So where there the fresh water is reaching up to the sea, then the agriculture is on one side is agriculture, on other side is the sea. So the fresh water, and if you see the satellite image where the fresh water reaches, the land goes inside into the tidal floodplain area, and where the fresh water doesn't reach there, the tidal floodplain area is moving very fast landward, and it's spoiling the fertile agricultural land. So fresh water, not only in the river Indus, but also in the canals which are offtaking from the Kotri barrage, should be supplied enough water so that it reach up to the tail end. So of course the levee is important, and I know that few years ago government has taken initiative for construction of levee, but I don't know what happened, and then it suddenly stopped. So levee is very important, and under that Sindh Coastal Resilient Project, they are going to construct the levee, and also, as I suggested, that that levee will have the dual purpose, that it will be the protect the surface seawater intrusion. Also, it will have the road over it, so that the communication between different communication of communities to the Karachi and other cities would be carried out, and their fish production will reach on time.
Thank you very much, sir. So we have another question from Dr. Ishtiaq Mandok. He's asking, first of all, he's commenting you on your very nice presentation. He's asking, can you please comment about reducing risk for the downstream and its impact in the changing climate in the upper areas of Pakistan, like Gilgit-Baltistan?
Yeah, Gilgit, because the upper region is actually the region which supplies the water, and Gilgit-Baltistan and the Hindu Kush, and you know very well that the river Indus starts from the Mansarovar Lake, and it goes to China, from Tibet, and then it moves to the Ladakh, and then Gilgit-Baltistan and Kashmir, and then Gilgit-Baltistan, and then KP, and then Punjab and Sindh. So the upper region is almost the from where the Indus gets the most of the water, and the lower area like Punjab, Sindh, and some parts of KP, they get water there. So we should have an integrated approach for the Indus basin, with two different approaches. For upper basin, it needs different approach. For lower Indus basin, it needs different approach, because The upper is actually the catchment from water comes, and the lower one is the area where the water of that Indus is being used. So two different approaches would be this. So especially if I talk about the lower Indus basin, the efficient irrigation methods and the recharge of the groundwaters will help, and the hill torrents, which are utilization of hill torrents, will help in improving the water resources in Pakistan. And also, when we say the groundwater, I know that few years back, the government of Pakistan has initiated the lining of water courses and canals and that one, without taking into consideration whether in those areas, whether the water is fresh or saline. Yes, if it's saline, then those areas needs to be lined. Those water courses and canals needs to be lined, because the water is saline, and if the water will seep out, it will be wasted. But if for those areas where the water is fresh, the lining of water courses and canals will result in negative impact, because if you stop the recharging the groundwater, it will be converted as saline. I would like to give one example of Larkana city, through which one of the canal, rice canal, is going through, and the water quality of the groundwater of Larkana was very good, very sweet water was there. But the government decided to line for 2-3 kilometers of the city area. And when they lined that one, and after 1 or 2 years, now the quality of groundwater is completely saline. So it converted into saline. So when we develop a mechanism for the whole Indus basin, then looking at the area and ground realities, we need to develop the mechanism. Thank you.
Thank you very much, sir. We will go towards the last question, and I think you can answer it in general terms. What will be the effect of Kalabagh Dam on the flow of water below Kotri?
Yeah, it's actually big bone of contention between different provinces. Yeah.
Yes.
Actually, the problem is the mistrust, which I see is the trust deficit between the provinces. That's the reason that if the dam is going to be constructed in GB and upper region, then since do not oppose a lot, though it opposes, but on Kalabagh Dam it opposes, because 2 or 3 more canals will be as per the people of Sindh think that the new canals are being drawn from that barrage, but that dam. And whole this area, which is barren area, that will be irrigated through it. And the 2 link canal, actually there are 2 link canals that have created a lot of problem, the Chashma Jhelum and Tonsa Pajana. But since there's the early sowing crop season, and it needs water initially, because Punjab is a late sowing area where the crops are sown little bit late compared to Sindh. When Sindh needs water, irrigation water, at that time, Punjab opens these 2 canals, and there's a lot of shortage here. Instead of taking water from the other 2, from the Mangala and that one, and the other observation of Sindh is that when these canals are the flood canals, when there's a plenty of water, then these should be opened. But when there's a shortage already in Sindh, at that time, the upper Punjab takes water. So now these 2 canals are not controlled. Even the IRSA says that these canals should be closed now. Punjab opens that one, means there's no control on that one. So what if the dam is constructed there? Then the Sindh will completely be ruined. It means there will be no water for the agriculture. There will be no water for that's the overall. I'm giving the perspective of the people. That's why they are opposing that one. So initially I said that there's a trust deficit. Looking at these 2 canals, how they are being operated, and that's the reason, I think.
Thank you very much, sir. And again, I would also like to thank our participants who joined us from different corners of the world. And again, thank you very much, sir, for
Thank
your
you.
time. And we are very grateful to have you and for your time. With this, we come to end of this webinar. Thank you very much for joining us. Hope to see
Thank
you
you.
in some other event of Comstech. Thank you very much and bye-bye.
Thank you. I am also thankful to Comstech. Thank you.
Thank you very much.